Okay, for today's lesson, we're going to be looking at converting between rational exponents, which is new to us, and then radicals, which we should know from last time. So let's do a little bit of a warm-up. Here we want to determine what number fits in the box and then fill in the blank. So 5 times 5 equals what? You can think about it as 5 squared, but that is 25, which means that 5 is the square root of 25, right? Okay. 10 times 10 is 100, so it means that 100 is the square root, 10 is the square root of 100. Okay, x times x is x squared, which means that x is the square root of x squared. X to the third times x to the third, good practice for our exponent rules, we add those exponents. We get 6, so x to the sixth means that x cubed is the square root of x to the sixth. What is the square root of a number? It is the number that you can multiply by itself to get that number, right? Or get that number, yeah. Okay, so we're looking for that number that you multiply by itself to come up with that. All right, so now we're going to think about what the square root of x means. So if I simply had the square root of x, remember x just represents some number, and we don't necessarily know what that number is, so it could be something nice like the square root of 4, which is super easy, or it could be something not as nice like the square root of 10, right? So let's go ahead and see what it is. Use that knowledge to fill in the boxes. So the square root of x times the square root of x. When you have the square root of x times the square root of x, we have the square root of x squared, which we know just equals itself, which is x. X technically to the first power. However, if I wanted to break that into two separate parts, think about this. We're saying I'm going to have some number plus that same number, and I should get 1. So how could I break it into 2 halves? I'd have a half each. So here, this is the same as saying an exponent of a half times the exponent of a half. So if you equivalate that, this first and this last part, the square root of x times the square root of x, and then here we have that these statements are the same. That exponent of a half represents that square root of x. So our rule here, when we have a to the 1/n, represents the nth power of a, or the nth root of a. So a to the 1/n is the nth root of a. A number raised to the power of 1/n is equal to the nth root of that number. So let's try these and simplify. Okay, so if I have 9 to the 1/2, that's the same as the square root of 9. And you don't necessarily need to write it with that 2. You can just write it like this, and that the default index is 2. So the square root of 9 simply equals 3 here. Okay, this next one is 54 to the 1/3. So we're doing the cube root of 54. So we're going to break down 54. We practiced this last time. So maybe you say it's 9 times 6. So then 9 is 3 times 3. 6 you can break down to 3 times 2. And in this case, since it is a cube root, we're looking for triples. So we have 3 3s, so we can pull out 1 3, and we're left with 1 2 on the inside. Okay, next, x to the 1/5 is simply the 5th root of x. And that one, since we don't know what x is, we can't simplify it anymore. Okay, what if I then have maybe not just 1 on the top of that fractional exponent, but I have a to the n divided by n? That is going to be the nth root of a to the n. So a number raised to the power of m divided by m is equal to the nth root of a raised to the n. There's lots of different ways to think about why this is true, but if you need to convince yourself, one way I would think about it is think about just breaking that apart. m times n is the same as m times 1 divided by n. So I could rewrite that as a raised to the n to the power of 1 divided by n. And then we know that that 1 divided by n is the same as the nth root of whatever we have inside the parentheses, which is a to the n. Not to say that that's the only other explanation, but that's one way to convince yourself that that's true. Okay. The reality is here, we mostly want to apply these rules, so you're going to be responsible to know how to convert between the two different forms and simplify things. So, if I ask you to rewrite an exponential form, that means we want some fractional exponent in most cases. So here, think about this. This is 5 squared times, or to the raised to the power of 1/3. Or you may just be able to realize that's just 5 to the 2 divided by 3, right? Because we multiply those exponents. Or you may just say, okay, well, anytime I've got that third root, we're going to divide our exponent by that number. Okay, in this case, a little bit different, but it's got the fourth root of 7 raised to the third power. So we're going to have 7 to the 1/4 raised to the third. So once again, we multiply the exponents and we get 7 to the 3/4. Okay, this one. So you got to remember, if there's no number there, that's really saying the square root, so 2 there. So this is 3, and then the exponent would be a half for the square root raised to the 5th. We multiply those exponents, so we get 3 to the 5/2. Okay, last but not least, this one we have the cube root. So one thing to keep in mind here, I would put whatever you have underneath your root in parentheses, so x to the 9th, y to the 3rd, and then raise to the 1/3. Because if you don't, you may forget to apply that exponent to both parts. You may just do like x to the 9th to the 1/3 and not do it to the y. So this 1/3 will apply to both parts. We're going to multiply that. So x to the 9 times a 3rd and y to the 3 times a 3rd. So we end up with 9 times a 3rd is x is 3, so x to the 3rd. And then 3 times a 3rd is just to the 1st, so x and then the y. Okay, rewrite in radical form. So this time we're going to do the opposite. We're going to take the fractional exponent and make it a radical. So here, this is the square root. Wait, we got a fraction of a half of 16. That one you should recognize. The square root of 16 is 4. Okay. Ooh, this one's a little bit tricky. I'm going to start and just make it a positive exponent. So that's 1 over 9 to the 5/2. Okay, if I want to get rid of that fraction, so the half part of it, that means it's the square root, so 1 over the square root of 9 to the 5th. And I could rewrite that, or I could evaluate that in my calculator. The square root of 9 is 3, and then raised to the 5th is 123. So that doesn't equal 243. I think I said that as 123. That was my bad. Okay, same thing here. This time, though, it's the cube root. So the cube root of 27 to the 2nd. So this one I'm actually going to rewrite a little bit differently. Let's do the cube root of 27 and then raise it to the 2nd. And you are welcome to do those in either order. So the cube root of 27 is 3, and then if I square it, I get 9. Okay, 8 to the 4/3. So this represents 8 to the cube root, right, of 8 to the 4th. And you may want to do the same trick we did last time. Let's do the cube root of 8 and then raise it to the 4th. The cube root of 8 is 2 raised to the 4th, gives me 16. Okay, they won't always work out like that, and a lot of times you can just leave it as a radical, but since these unsimplified, we went ahead and did it. Okay, this time, we want to rewrite and then evaluate without a calculator. And we just practiced this, similar to here. Okay, so something like this, I am going to think about it in terms of, I think the roots make more sense to me. So this is the same as the square root of 16 to the third. But this will be easier probably to do the square root of 16 and then raise it to the third, because then we'll have a smaller number that we're, cubing. So here we do get the square root of 16 is 4. So 4 cubed, you get 16 is 4 times another 4, we get 64. Okay, this one, ooh, okay. 32 raised to the negative 3/5. I'm going to start by doing it 1 over 32 raised to the positive 3/5. So we're going to have 1 over the 5th root of 32 raised to the third, which I'm going to do that as, let's just figure out the 5th root of 32, and then once we find that answer, we'll cube it. So the 5th root of 32 is 2, and then 2 cubed is 8. So this answer is equivalent to 1/8. Okay, let's do it again. Since there's a 3 on the bottom, we're doing the cube root of 125 squared. I'm going to start always, it's easier to do the cube root and make the smaller number before making it bigger when you square something. Not to say it wouldn't work if you do it the other way, but especially here we're not supposed to be using a calculator. So the cube root of 125 is 5, and then we're squaring it and we get 25. Okay, one last one. So this time, once again, it's a negative exponent, so I'm going to do 1 divided by the positive exponent of 4/3. So we can do 1 over the cube root of 8 to the 4th. And then we get 1 over the cube root of 8, let's just do, and then we'll raise it to the 4th power. So we get 1 divided by the cube root of 8 is 2 raised to the 4th. So then we'd get 1 over 16. Okay, these last ones are to challenge you a bit. We're going to apply our exponent rules. I always think it's easier. Remember all those last time where we had those shortcuts? So if we actually have the exponents as fractions, it will probably be easier here. So I'm going to start just by writing these as fractions. So the square root of 3 is the same as 3 to the 1/2 times the square root of 8 is 3 to the 1/4. Sorry, that is the 4th root of 3. I think I said the square root of 8. Okay, the 4th root of 3, so 3 to the 1/4. So our exponent rule here when we're multiplying is that we add our exponent. So we're going to add 1/2 plus 1/4. Feel free to pull out your calculator if you don't necessarily want to do that mentally, or you could think about making common denominator of 4. But when you add that exponent of 1/2 plus 1/4, you get 3/4. You could leave it like that, or we could rewrite that as the 4th root of 3 to the 3rd. Okay, so let's look at this next one. This one is saying x to the 3/4 divided by x to the 2/8. So here what we're going to do is we're going to subtract those exponents. So we have x to the 3/4 minus 2/8. This one's a little bit easier because if you simplify 2/8, notice you get 1/4 again. So we're doing 1/4 minus 1, 3/4 minus 1/4, and 3 minus 1 is 2, so we end up with x to the 2/4, which is the same as x to the 1/2. So we get the square root of x. Okay, one last one. Let's always get rid of our parentheses first. So we're first going to distribute that exponent of 2, so raise things to the 2nd power. So we'd have x squared y to the 1/2 times 2 all over x. I'm going to write that as 5 divided by 5. Oh, this is a lot easier than it looks like. So we've got x squared. 1/2 times 2 is just 1, so that's just y. And I'll put a first there just so we remember. And then x, 5 divided by 1, is 1, so x the first. So here, the only thing I can combine is my x's squared minus my x in the bottom. You may just realize that the x squared divided by x is x, because we've been studying that a lot. And then we have y. We've got our final answer. Okay, this should guide you enough to be able to do your assignment today. Good luck.